Today we're going to continue our study of propositions. And as I've said, there are three important reasons that we're studying these. One is we're looking at logical dependence between propositions. Another is to understand better logical equivalence between propositions. And then finally to understand validity. Now, as far as logical dependence goes, we're going to be focusing on this today. When we talk about logical dependence between propositions, basically what we're looking at here is we're assuming that if one proposition is true, what can we know with absolute certainty about the truth of another proposition? Alternatively, if we were to assume one proposition is false, what can we know with absolute certainty about the truth of another proposition? And we do this all the time, in fact. We'll take a statement like, if I were to say, all students are smart, or if I said, probably put it, every student in my class is smart. What would that say, or what would that imply about the following proposition? No student in my class is smart. If they're all smart, can it also be true that none of them are smart? It doesn't seem to be the case. So what we would say is that the truth of that first statement implies the falsity of the second statement. And this is what we're going to be studying. We're going to be looking at the four categorical propositions that we've discussed so far, A, E, I, and O. And we're going to be asking about the logical relationship between these statements. And the way we're going to do that is we're just going to begin, and you can start anywhere you want it, but we're going to start with A form propositions and just say, okay, well, let's assume this is true. Let's just assume that all S or P's is true. Then what can we know with absolute certainty about the truth values of these other statements? If all S or P is true, well, is no S or P, is that true? Is that false? Or is another possibility, maybe we just can't know. That is actually going to be one option as well. So again, if all S or P is true, what can we know with absolute certainty about an O form proposition? Is it true, false, undetermined? Again, if we know that, if we're assuming that an A form proposition is true, what can we know with certainty about an I form proposition? Likewise, we're going to ask, well, let's assume that this statement is false. Then what can we know about certainty, with absolute certainty, about the other ones? So we're going to begin, and like I said, you could start anywhere, but we're just going to begin with an A form proposition and ask, assume it's true. Then what can we know with absolute certainty about an E form proposition? And if it helps, you can provide, you can substitute more concrete examples in place of the S and P. So you could take something like, all students are smart. If it's true that, let's say, all my students are smart, or all the students in my class are smart, can it also be true that none of them are smart, that no student is smart? It doesn't seem so. It doesn't seem to make any sense. If they're all smart, then it's simply false that no student is smart. And this is something we know about the logical relationship between an A and an E form proposition. If A is true, then the E form proposition is false. But it goes in the other direction as well. For if we were to assume, for instance, and I don't have a slide on this, but assume that no S is P. Assume this is true. So assume that no student in the class is smart. Could it also be the case that they're all smart? That doesn't seem to make sense either. If none of them are smart, it can't be true that they're all smart. So if an A form proposition is true, that means, and it requires, that the E form proposition is false. And if the E form proposition is true, that means that the A form proposition has to be false. So hopefully the way I've worded it down here isn't confusing, but if A is true, E is false, and if E is true, A is false. Hopefully you can see that what's in the parentheses, those go together, whereas what's outside of the parentheses, those go together. Well, let's ask, what if A form proposition is false? What if it's not true that all the students are smart? Then what would be the truth value of no S is P? What is this true? Is it false? Well, could we know for certainty that it's true? If it's, so this is going to get a little confusing, but if it's not true that all students are smart, does that mean that none of them are? No, it doesn't mean that none of them are. It doesn't mean that at all. Because it could be that some are smart and some are not smart. And so we can't determine with absolute certainty that this is something that is true, because it could possibly be false. Now, it is also possible it could be true, because maybe the reason that the A form proposition is false is because none of them are. Maybe every student in the class is dumb. So it could possibly be true, but it could also be false, just in case some are and some aren't. And so we can't know the truth value of this. If suppose someone, all they gave you was the statement, it is not true that all the students are smart, you couldn't know whether they were all dumb students or whether some were dumb and some were smart. You couldn't infer that correctly from that. And so we can state this with certainty, that if an A form proposition is false, then the truth value of E is undetermined. And just as before, this is going to work the same in the opposite direction. If no S is P, if this were false, well, we couldn't determine with absolute certainty that all S are P, because it might be the case if the E form proposition is false. Well, maybe it's false because all students are smart, but maybe it's also false for the simple reason that some are and some aren't. So we can't know with absolute certainty the truth value of an A form proposition just given the falsity of an E form proposition. And we can also draw a further conclusion from this, and the further conclusion is that it is just not possible for both A and E form propositions to be true. That an A form proposition and an E form proposition, they cannot be true at the same time. If one of them is true, the other is false. However, it is possible for both to be false. Because suppose this were the scenario that some S are P and some S are not P. Well, then it would follow, if some S are and some S aren't. If both of these statements down here at the bottom were true, it would follow that the two at the top are not true. So it's possible for both A and E to be false, but it's not possible for both of them to be true. And this is a specific relationship that exists between these two propositions, and we call the relation here, we say that all S are P and no S are P, we say these are contraries. They're contrary to one another. So this is a technical term we're going to use, and you need to be able to distinguish contraries from another term I'm going to give you in just a second. But this is a relationship of contraries between A and E form propositions. Okay, so let's continue, and let's assume, and we're going to move along this little square we have here. It's called the square of opposition, if you hadn't figured that out from reading the top. But let's assume that an A form proposition is true. Now let's move down here to an O form proposition. What can we know about this? So let's assume that all students are smart. Can it also be true that some of them are not smart? And the answer to that seems to be no. It is simply false. If all the students in the class are smart, then it can't be true that some are not. So we know that with absolute certainty. And here we can state the relationship that exists here, that if an A form proposition is true, then the O is false. And I got a little ahead of myself, but let's work in the opposite direction. Let's assume that some students are not smart. Well, then can it also be true that all of them are? It doesn't seem to be so. If some people in the class aren't smart, then it's just simply false that all of them are. And so here again we have this kind of reciprocal relation where if an A form proposition is true, then it follows that the O form proposition is false. And I should have added here, and I didn't do this, but it's going to work from this corner up here from E to I as well, and I should have included this. But if no S is P, if that's true, then it's going to follow that some S are P can't be true. Because think about it. If no student is smart, then it can't follow that some are. And vice versa. If some students are smart, it can't be the case that none of them are. So I should have included that on here, but hopefully you can see that this corner to corner, if one is true, the other is false. All right, well, let's assume that an A form proposition is false. then we can ask, what is the truth of an O-form proposition? So if it's not true that all S are P, if that is false, then what is the truth of some S are not P? And it seems like if this is false, then it can be false only for one of two reasons. It could be false either because none are, or it could be false because some are and some aren't. And either way we go, it seems like if an A-form proposition, if it's not true that all S are P, then it must be true that some aren't. And so you can see that if an A-form proposition is true, it's going to follow that the O-form proposition, if the A-form is false, it's going to follow that the O-form proposition is true. And what about in the other way? What if we assume that some S are not P? What if we assume that that is false? What if we were to assume this is false? So it's not true that some S are not P, and this is a little confusing. Well, then it's going to follow that this statement up here is true. So this relation here, I'll just list it as such, is if A is false, then O is true. And if O is false, A is true. And it's going to work the same from the top right corner to the bottom left corner, from an E form to an I form. If E form proposition is true, then I is false. If E form proposition is false, then I is true, and vice versa. And I'm getting a little ahead of myself, but the point here is, and this is, I think, the maybe an easier way to even understand it, is that what we have here is from corner to corner, these propositions have the exact opposite truth values. They always will have the opposite truth value. If the top left is true, then that means the bottom right is false. If the top left is false, that means the bottom right is true. And the same up here. If the E form proposition is true, I form proposition is false. If E form proposition is false, I form proposition is true. And we call this relationship here, we call these contradictories. And I know a lot of times in ordinary English we'll just say contrary. What you're saying is contrary to what I say. What you're saying contradicts what I say. But here we're using these terms in a technical way. And this one might be, honestly, the easiest relationship to remember for the simple reason that you can think of it on the square of opposition as this x here. These are xing each other out. They're contradicting each other. And just know that the truth value of this is always the opposite of the truth value of this statement, and vice versa. And the truth value of an E form statement is always the opposite of the truth value of an I form statement. They contradict each other. They X each other out. All right, well, let's continue. And now we're going to assume that an A form proposition is true. And if we assume that, then what can we know about an I form proposition? What is the truth of it? And here, let's just assume, let's say all the students in the class are smart. Well, does that imply that at least some of them are? And I know sometimes you'll say, well, some, means a couple, but the way we're using the word some here, it means at least one. So if all the students are smart, does that imply that at least some of them are? And the answer to that seems to be yes. If everyone in the class is smart, then it goes without saying that some of them are. Now, there is one small exception. I'm just going to throw this out here and then we're going to move on. The only time this doesn't apply is when we're talking about fictional entities. If I said all unicorns have a horn, would that imply that some do? Well, no, because there are no unicorns. But barring talk of fictional entities, whenever we're talking about real entities, it's going to imply if all S are P, that some S are P. And the same thing can be said over here. Suppose we say that no S is P, so no students are smart. Does that mean at least some of them, at least one is not? Yes, it will. So the same relationship is going to exist over here. The truth of the statement at the top, so what we have at the top of our square of opposition, that implies if the one at the top, if A is true, that implies that an I is true. If E is true, that implies that O is true. So I'm just writing it up here for you. Well, let's continue. Let's ask, what about if A is false? If it's not true that all S are P, then what is the truth of some S or P? And the reality of that is we can't know. It's undetermined. Why? Well, we have to ask why, under what scenarios would this be false? When would all S or P be false? Well, it could be false because some S are P and some are not, in which case some S or P would be true. But it could also be false just in case no S or P, in which case some S or P would be false. So we can't know for certainty what the truth value of this is. Same thing right here. If no S or P is false, well, it could be false either because some S are P and some S are not, in which case, it would be false. Or it could be false because all S are P, in which case some S or P would not be true. So the statement at the top of the square of opposition, whenever it is false, we can't know what the truth value of the statement below it is. So if an A form proposition is false, then I is undetermined. And if E is false, then O is undetermined. Well, let's ask another question. Let's go not from the top down, but from the bottom up. Let's assume that some S or P is true. Then what would be the truth value of all S or P? If some S or P, can we know for certainty that all S are? Well, it's possible the reason that this is true is because all S are P. Then again, if this is true, it could also be possible that some students are smart and some students aren't. So here again, we can't know. If we know that some S or P, we can't know with certainty whether or not all S are P or all S aren't P. It's possible they could be. It's possible that it might not be true. Same thing over here. If some students are not smart, well, maybe some students are not smart, but some students are, in which case the E form proposition would be true. But maybe the reason some students are some S are not P is true is because none of them are, in which case that would make no S is P true. And so we can't know for certainty, given that an O form proposition is true, we can't know for certainty that this is either true or false. So here again, I'll just state it for you so you can see it. If I form is true, then A is undetermined. And if O is true, then E is undetermined. And let's do one more. If we assume that the statement here at the bottom is false, now we're asking if this is false, what is the truth of this? If this is false, then what is the truth of this? And here's where our contradictories really, why this is going to become important. I'll put this back up here. But remember what I said, if this is false, right? If this is false, then what does that mean about this statement up here? Well, that must be true, right? If some S or P is false, then the statement at the other corner from it must be true. And if this is true, remember we said if no S or P is true, then can it possibly be the case that all S are P? And the answer to that is no. And so if this is false, we can know with certainty that the statement above it is false. And here's where our square of opposition really helps us out, because like I said, if we remember that what comes at the corner from the statement has the opposite truth value, so this is false, so this must be true. And we remembered from learning about contraries that if an E form is true, then the A form must be false. Then we can know with absolute certainty that this is false. The same thing is going to apply on the right-hand side. If this statement, if an O form statement is false, well then that would mean that an A form proposition is true. And if the A form proposition is true, that would mean that the E form proposition, no S is P, is false. And so just like on the left-hand side, if the bottom statement is false, that means the one above it is also false. And I'll just list that up here. If I is false, then A is false. If O is false, then E is false. So this is interesting to note because we can also infer a following claim, which is that it is possible for both statements to be true it's also possible for both statements to be false at the same time. So you see here the differences between the various relations that exist. As I said, when we talked about contraries, both couldn't be true, but both could be false. When we talked about contradictories, both couldn't be true and both couldn't be false. When we talk about these two relationships, the one above and the one below, both can be true, both can be false. And we call this relationship here, we call these subalternates of one another. And notice here how this arrow goes down. What this means basically is that if this is true up here, it implies that this is true down here. But the relationship of the arrow doesn't go back up for truth. Now, I will say this, it does go back up for falsity. If the one at the bottom is false, then the one at the top is also going to be false. But the arrow is meant to imply that truth goes down. When you look at the arrow, think, oh, well, if this one is true, this one must also be true. All right, so finally, we're going to do the two at the bottom. Assume that an I-form proposition is true, so some students are smart. Then what can we know about the truth value of this? If some students are smart, can we know with absolute certainty that some are not? And the answer to that is no. Its truth is undetermined. Why? Well, if some S or P is true, then why would some S or P be true? Well, maybe some S or P is true because some students are smart and some students aren't smart. That's a possible state of affairs. In which case, the O form proposition would be true. Some S or not P would be true. But it's also possible that this is true because all the students are smart. And if all the students are smart, that would imply that the O form proposition is in fact false. So there are scenarios under which if an I form is true, it could be the case that the O form is false. It could also be the case that the O form is true. And we just can't know based on this alone, just based on I form proposition being true, just based on that, we can't know whether or not O is in fact true or false. And the same is going to apply if we go in the opposite direction here. If the O form proposition is true, then I is undetermined. Okay, so let's ask one final question. If we assume that the I form proposition is false, so we say, well, it's just not true that some S or P, then what is the truth of the O form proposition? And here again, our contradictories are really going to help us out, because if this is false, that must mean that this up here, the E form, is true. And if no S or P is true, then we got our arrow right here. And what is that telling us? If this is true, this must be true. So if the I form is false, that means that the E form is true, because remember, what's at the corners has opposite truth value. So if this is false, this must be true. And then the arrow, truth goes with the arrow. So if this is true, E is true, that must mean that O is also true. And the same is going to apply if we start right here. If we were to assume the O form proposition, some S or not P, if we were to assume that that is false, then that would mean that all S or P, the A form proposition is true. So O is false, means A is true, and if A is true, that means I must also be true. So, and I'll just list that for you here so you can see. If an I form proposition is false, then O is true. And if O is false, then I is true. And we can draw a conclusion from this also, which is that both I and O, it is possible for them to be true at the same time. It could be the case in some scenarios in which both are true. But what is impossible is for both of them to be false at the same time. There is no scenario under which both of these would ever be false. So whenever you're dealing with categorical propositions, I or O, one or the other, is always going to be true. All right? It's never going to be the case that both of those are false. Now notice that's not the case for other propositions because, for instance, the two at the top, contraries, there are some scenarios under which both of those could be false. But that's not the case down here. And we call these propositions at the bottom subcontraries. And here is our what we call our square of opposition. It shows the logical relationships that exist between these four propositions. And who knew it could be so complicated? And some of you might be a little frustrated because this is hard. You might need to go through this lecture again because some of these concepts can be a little tricky. Slow it down and repeat things. This is one of the more technically difficult things that I think we'll cover this semester. But it's important, even apart from what we're studying right now, just to be able to think in these terms like, okay, if what you're saying here is true, then what can I know with absolute certainty is true or false based on that? If what you're saying is true, is this other thing undetermined? If what you're saying is true, is this other thing false? That's basically what we're working on right now, is kind of honestly just abstract thinking, to be able to think in terms of assume such a proposition is true, what else must be true or false based on it? So this might seem pretty far removed, and it is very abstract, but I think you'll find that it can be helpful for other kinds of difficult abstract thinking as well. Anyways, like I said, you'll probably need to go back through this and listen to some of this again. You will have a homework assignment. Before I get to that, I'm just going to put everything here so you can see it. Just a nice, neat presentation of all the different relationships that exist between the propositions. Like I said, I should have, when it came to the contradictories, also I just listed the relationship between A and O. But when it comes to contradictories right here, the same is going to apply to E form, no S is P, and I form, some S are not P. The same statements are going to apply right here as well. So, like I said, you do have some homework, and I have it right here. If you have any questions, please shoot me an email or let me know, and I'll do my best to help you out.